Okay, Jane, I thought I'd do a video for this one because it gets pretty complicated and you really have to know some stuff about Texas Holdem to do this problem. These are your community cards. You can see those on the board, so can your opponent. These are your whole cards, 2 of them, which you can see but your opponent cannot see. Now, the cards on the board determine the number of hands of each of these types that you can get. For example, a straight flush, if you had a straight flush in spades, it might look like this. So since I put the spades there, I can say that the straight flush might look like this. 3, 4, 5, 6, 7. 5 in a row of the same suit. That's a straight flush. Well, based on the what the board looks like will determine whether straight flush is even possible. So like if let's just organize this hand into spades, hearts, diamonds, and clubs. And think of 13 cards in the suit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I kind of ran out of room there. Let me erase this part. And so the spades that this guy has, that the board has, is the king of spades, which goes here. We're going to put them in order. He has the 7 of spades, ace, 2, 3, 4, 5, 6, 7. And he's got the 10 of spades, 8, 9, 10. And by the way, you can have, there actually should be 14 cards here because your ace could be low or high. So, but the point is, with these 3 spades on the board, and he's got only 2 cards in his hand, we don't know what they are, is there any 2 cards that would give him a straight flush? Well, if he had the 8, 9 of spades, we could fill this in right here. But there's no more cards to fill in. He cannot get 5 in a row. So the probability of a straight flush is 0. Okay, there's just no hands. Oh, and by the way, how many possible 2-card hands can this guy solve? This is what's going to determine probabilities. Okay, so there's 5 cards on the board. There's 2 in your hand. That's 7. So his hand is going to be taken from the other 45 cards. He's got 45 cards to pick from, and he's got 2 of them. So we can calculate the number of possible hands he has by this. The combination of 45 things taken 2 at a time. That's all the possible hands he can have. And his hand can't contain any of these 7 cards. So I think if you remember, that's 45 times 44 divided by 2. 2 factorial. And this goes into here 22 times, so 45 times 22, whatever that is. If I go to Desmos, combination of 45 things, taken 2 at a time, 990. So he's got 990 possible hands. And when you start figuring out probabilities in question number 2, you'll be putting his total number of hands for each one of these over 990. Okay, what's the probability of 4 of a kind, or the number of hands that give him 4 of a kind? Well, he can only have 4 of a kind if there's already a pair on the board. So the only pair on the board is 7 of clubs, 7 of spades. So his hand has to look like this: 7 of diamonds, 7 of hearts. That's the only way he can get 4 of a kind, is if that's his hand. Then he would match that up with the board, and he'd have 4 of a kind, 4 sevens. So there's only one possibility there. Okay, and if you were a Texas Holdem guru, you would know that the only way to get a full house is if there is a pair on the board. So he's got 7 of clubs, or the board has 7 of clubs, 7 of spades. He needs to have a 7 here, of which there's 2 to pick from. So one of his cards has to be a 7 to give the 3 of a kind part. And then he has to have either an ace, a king, or a 10 to give him 2 of a kind. So let's see, he's got the ace of hearts on the board. And then for an ace to make another pair, there's 3 aces to pick from. So we could say he's got a combination of 3 things taken one at a time, which is just 3. 3 aces to pick from. And by the way, so the 7, he could have the 7 of spades, 7 of diamonds, or 7 of hearts. Or 7 of hearts. So he's got 2 to pick from there. What about kings? The king of spades is on the board, but the king of diamonds is in my hand. So he can't use that one. So he's only got 2 to pick from there, the king of hearts or the king of clubs. So we've got 2 there. And for the 10 of spades, that's on the board. Guess what? We've got the 10 of diamonds in our hand. Oh, this is supposed to be a diamond. 10 of diamonds. So he can't use that one. So his hand has to have either the 10 of hearts or the 10 of clubs. So there's 2 to pick from there. So he could have the 7 of diamonds and the 10 of hearts. If he had that in his hand, he'd have a full house. He could have the 7 of diamonds or the king of clubs. And then he'd have a full house because he'd have trip 7s plus a pair of kings. Full house, which beats your 2 pair, by the way, because you have a king, two kings and 2 10s. So the question is, how do you count all these possible hands? I'm going to pause the video for a second. Okay, so the fact is that we know he's got to have one of these 2 cards. And then he's got these possibilities for his other card. So if you want to actually show the calculation, it's the combination of 2 things taken one at a time. That's the 7s. There's 2 7s to pick from. For his second card, he's got 1, 2, 3, 4, 5, 6, 7 to pick from. But we're only going to take one of them. So 7 things taken one at a time. So 14. 2 times 7, 14. So the number of hands, the hands that he has that give him a full house are 14. Okay, so the probability that he has a full house, by the way, is 14 over 990. What about a flush? Well, a flush means they don't have to form a straight, like a straight flush. They just have to be 5 cards of the same suit. Well, the only way you can get a flush in Texas Holdem poker is if there's 3 cards of the same suit on the board, and we do have spades. With 3, if there's not 3 spades or 3 of the same suit, there's no possibility. So we've got we've got king of spades, 7 of spades, 10 of spades. He needs 2 more spades in his hand to complete a flush. So how many possibilities are there? Well, there's 10 spades to pick from. You don't have any in your hand, so there's 10 left over. So the number of different hands that he has that will complete his flush is the combination of 10 things taken 2 at a time. So for example, he could have the ace of spades and the 2 of spades. That would give him a flush. But what is this? Well, it's 10 times 9 divided by 2 factorial, or 45. The probability of a straight. To have a straight, you have to have some cards that are kind of close together. So I can see ace, king, 10. And I can see 7. You only got 2 cards to pick from. I can't complete a straight with 7, 8, 9, 10. It doesn't get me there. But if I could get a queen and a jack in here, I would have a straight. Doesn't matter what they are. So how many queens and jacks are there to pick from? There's 4 queens and 4 jacks, so there's 8 cards to pick from. But well, I need a queen and a jack. So I have 4 things taken 1 at a time, 4 queens times the combination of 4 things taken 1 at a time. That's 16. So for example, he could have the queen of spades, and then he could have the queen of the jack of spades, the jack of hearts, the jack of diamonds, or the jack of clubs. 4 times 1 is 4, but then he could have the queen of hearts with any of the 4 jacks. So the point is there's 16 hands that he could have that would give him a straight. Okay, now I'm going to pause. I'm going to stop the video there. I'm going to tell you that this is the hardest one to calculate, and let you think about that for a while. But if we add up all of these are the hands that are better than your 2 pair. Okay, these hands are going by rank from best to worst. So everything above G, 2 pair of higher ranking than your own, will give you a hand that beats you. So if you add up all those hands and divide by 990, you'll have the probability that you're beat. Okay, so we'll leave these blank for right now and let you think about it. I don't want to make this video too long.